This video is intended for the Innovation Lab at DuPont Ball Library at Stetson University. In this video, we will go over how to align scans from one scan by separating it into smaller ones and also aligning multiple scans. To show you, this is a single scan done of a character. You can see it has very jagged lines, but just to let you know, this scan, even though it has jagged lines and a lot of extra data, can turn into this. Pretty clean finished product. This is just a sample scan to show you that we can go from this to that. This character is opened up in another file that I'm going to open up now for our demo purposes. We will be using this scanned model of Bowser, a character from the Super Mario world, to demonstrate these two types of alignment. Now you're going to see a lot of scans off to the right. They're just pre-prepared so that I can better move through this demonstration for you. We will start with the multiple scan alignment first. This demonstration will be shorter than the next part, where you take one scan and you break it down into smaller ones. Taking multiple scans of an inanimate object can benefit you, as some scans miss certain areas that other scans picked up. So this method of aligning scans will, in a sense, combine all the areas so that a more complete model will be made. Let's take a look at our model. You can see we have 3 different scans that I had done, and these are the fusion scans, the fusion settings. After each scan was done, the computer with each one saw the model as being complete in this form. In the second scan, this form, and in the third scan, in this form, as being complete. But I will show you that at the end, even though this is not too bad looking, if this suits you when you scan your model and you don't mind a little bit of rounded edges, then you can proceed. But there are certain things where if you do a certain method of refining your object, you can get a scan that turns out like this. You see, certain things are just highly defined. For instance, this portion right here. In the beginning, you hardly have any definition, but at the end, you have more definition just by doing a couple of edits and following a method that can definitely enhance your model. So let's start. We have these 3 fusion scans, all facing different directions because they were taken at 3 different orientations. What I have done is I've taken these and put them in order down here to show you how we can multiply align them. I took away all that wall data that surrounded each one. You select, as you can see right here with the eyes, which ones you want shown. That will help the computer understand which models you want to align. We'll start with doing auto alignment, which the computer just sees what's there and tries its best to configure all of them in the same orientation. Taking out the wall data probably will make this a lot quicker. This should take about another 20 to 30 seconds. I had done another one where I put it off to the side, where I'll show you I had the wall data in there with these Bowsers, and when it aligned, it took about 3 minutes. So if you want to quicken the speed of the algorithm for kind of orientating all your multiple scanned models, then you might want to just get rid of that extraneous data. As you can see, that's what it did. It took all 3 and pretty much put them right together. So I'm going to click apply. If you don't like what it did, you can click cancel and then do other edits yourself, or just align 2 instead of all 3 scans. Or if you have, let's say you were scanning 5 or aligning 5 different models together and you didn't like how it came out, you could start with 2, then move on to 3, just to see how well it puts it together. But I'm going to hit actually cancel. I'm going to hit cancel on that. Yes, I'm sure I want to exit. For instance, I could just take the 2 models right here and align them. Now you can also align them by creating pairs as well. So with this multiple scan, you could take, say, new pair, and you can make up to 3 pairs. So I know that this part of his front cheek we'll go to this part here, and let's see, what else could we do? We could do the top of the eyebrow. Actually, let's do this eyebrow right here, goes to here. And what else would be a good one? Probably the hands. We know that this portion of the palm right here would go to here. And then you can click Align. And you can see right there, it put them in such a way where it oriented to where you put those 3 different points. And there you could click Apply as well and keep the, and there you see it is still aligned and it's back in the workspace area. You see that third one is still out of line because we didn't include that this time around when we did a multiple alignment. But this is the one where I want to show you it can also align with the wall data if you didn't get rid of it. And it did a pretty good job, but it just took longer for it to calculate. We'll get rid of that. Let's add this to the mix. So even if you align 2 and you want to get that third one in there, you could do that. You could still hit auto alignment, which works, but like I said, if you want to manually do this, you can also click on which scan you want to move. The blue one remains stationary. You cannot move that one. The green ones, though, however, you can click on, and if you do a combination of the shift and then different mouse movements, like for instance, this left button is doing an orbit to the green model, you can see the blue is staying stationary. Or you can move your mouse scroller so it can zoom in and zoom out, or you can use the pan button on your mouse. In this case, it is the middle mouse button. If I click on it, you can see that I can pan it back and forth. If I orient it again, you see I'm getting closer to where it's supposed to be, like that. So use those key combinations while holding down the shift key to make it close. And if you like it close enough, or you can keep on further doing it to get it exactly where you need it, or if you get it close like this, then you can try to start doing your new pairs so you can make it align better. Do this, this. So yeah, that is much quicker. This one and that one. Go align, and it aligned it right back up. Okay, maybe not exactly. No, looks good. Okay, and I'm going to hit apply to that. So all 3 are now aligned. And after this point, then you can go, like I explained in the other videos, go back to your tools and then do global registration, sharp fusion, small object filter to get rid of any kind of small objects. And then if you want to refine and simplify, you can do fast mesh simplification to reduce the size of your end result model. Now for the second part of this demonstration about aligning scans, we're not going to go into different scans, but we're going to take a single scan and we're going to reduce it. We're going to chop it up so that we can create, in a sense, multiple scans. Here's what I'm explaining. So we have this first scan. Oh, by the way, Fusion 1 scans. If you see EVA scan 1, and then you see the Fusion about to be right there, Fusion. I explained in the other video, if you are not going to be working with these files that the computer has made, you can get rid of them. So I essentially could get rid of this one and just delete. I can get rid of this one, just delete it, and as well as this one. These are the 3 different scans, and then delete it. Since I'm going to be trying to refine something along the lines of this. So once again, let's see, do I even have one? I have the raw scan right here. There we go. So I turned this scan, deleted all the wall information, and I also deleted the pedestal that Bowser sits on, and I came up with this. Okay, I guess I didn't delete the pedestal that Bowser sits on this one, so I could do that right now. Once again, you can go to the eraser tool, do cutoff plane, use the control key, click on the plane that of existence that you want to be straight, like that, and then control shift, do the mouse scroll key down or up until you get it where you need it to be. Then you can click erase, and erases everything below. And so now we have a model. You can see, just like by the previous example in the first file that I opened, that it was jagged. This one's even more jagged with seemingly different types of scans that repeat themselves over different parts of Bowser. So what we're going to do is this. We're going to open this up, and the way to open up a scan is to double click on it. Now this I'm going to describe to you in the simplest way I can. These are frames 0 through probably, I think it was 1300, yeah, 1312. While the 3D scanner is flashing, it's taking pictures. These are all the pictures that it's taking to go ahead and form your model. So there's a lot of frames, and these frames are all the pictures that it took to create your model. For instance, if I keep on selecting, which I'm shift, scrolling down, selecting more, so it's including more of the pictures it took into the object, you can see that the object gets more and more complete as I scroll down and hit the shift and click. It's including those frames so you can see all those pictures together. You can see that's coming out really nice too in the back on the shell. But then when we keep on going, we have more information, a lot more information that kind of sticks there and creates those jagged elements. Because now I'm taking pictures of this side, and as the flash was going, it was adding certain things it saw to the other parts of this, to Bowser's shell. But what I would suggest is this, going from the beginning to the middle. Since we have 1300, we'll just go like here, 706, and seeing how well that looks. You can see that there's certain inaccuracies right here. Like you have a part of the spike here and another part of the spike there. So there is definitely a tracking issue when it must have missed tracking and then started all over again with tracking a different part of the shell. It has a different beginning orientation. So what we can do with this single scan is go back and start breaking it into pieces. For instance, I'm going to go back until this second shell, or this second spike, is eliminated. So I'm going to go further. See that that looks good. I'm going to go back a little bit, back a little bit more, because it looked like we had a problem. Right there is kind of where that shell, this shell, started appearing right there. So I'm going to go back a little bit more. Now I'm going to take this first part, even though it's a complete revolution of Bowser. I'm going to take it, I'm going to separate it, because I could kind of call that one the first scan. So what you do is when you find all the frames that you want to separate out, you right click and don't delete them, but move them to a new scan. And if I go back, and this button up here, top right, is back to workspace, you can see that it actually created the other scan right here, 517 frames. So that's the purple now. That's this. That's what I just separated. And apparently on this single scan, I must have went on a revolution of 3 times. Because we'll see from here, even though that was complete Bowser almost on the other scan, I can go down here, and once again I have another pretty much complete Bowser. So it revolved about 3 times, I'm sure. Okay, now let's do this again. So I'm going to go halfway, and I'm not so sure I want to work with that half, so now I'm going to go the other half. So 986 to 1300. Take a look at that. They both look kind of the same as far as one not being more simple than the other. So I'm going to go back up the frames, and you can see that right now, right about here, is where it starts to get a little bit more messy. Right there, all this extra data around this spike and a couple other spikes, you get more data. So I might try to separate that out. So I'm going to go to where it looks good, which is right about here. You can see those pictures being added one at a time. It's getting there. It's mostly from the left-hand side. Right about here is good. It's actually still building up on itself, so I'm going to go down further. Except for here. we got all this extra stuff right here. I'm going to see if I can find these frames and eliminate them because they're just extra data that looks like they came from a bad scan. So go down here. See, I'm getting close. They haven't moved yet. Okay, we're still going. Looks like we're getting closer. Not, oh, almost. There's some of them moving right there. Oh, it was right near the beginning. Okay. So I'm not sure I like how that's being put in there. You see right there, there's a big jump right there, right on this spike. If I click right there, frame 997 starts including a different set of orientation. So what I'm going to do is I'm going to take from, let's say, 997, okay, 996, and this previous spike, see if I can get rid of some of the stuff that looks like it's multiple. You can see it just looks like it's beginning at different points. It is not solid. So I'm going to take these, I'm going to put them in another scan. And when you get things like that, where it's just a lot of data that you don't think you're going to use, you can rename it. So it's simpler for you to get rid of it. And usually what I do is raw scan, and I do discard. If I call it discard, then I don't have to deal with it anymore because I know I do not want it as part of the model. So here, I get rid of it, and the model looks a little cleaner. There's a lot less going on around the arm and this side of the shell, as you can see. That was the previous scan, and we can go back in here and take a look and further separate anything else. But what I'm doing also is making different scans. So even though you had a single scan, let's say it still revolved 3 times, so I'm able to pull out almost full sculptures of the Bowser. But it doesn't have to be more than one revolution either. You can take different parts of it and work on it. For instance, if I was working on the model of a human head, I could take out parts that are only related to, let's say, the rear part where the neck meets with the hair, and work on that separately, or separate the left anatomical part of the face from the right anatomical part of the face, so I can work on different ridges, like for the nose and things like that, and see it from both different sides while creating the human face. But that's why creating multiple scans from one scan could be important. Let's do one more. Go in here. And the more you spread it out, the easier it is to work on it. So if I go here, go down. You can see that now I'm working on this side as I go backwards. You can see a lot of different spikes are in the wrong area. So it's a little time consuming to go through it this way. Okay, there we go. And moving this way, I see that I'm not getting any better results. So I'm probably going to start a little bit higher. Let's see. Looking for the spikes. There's some spikes. Okay, so I'm going to start here, move down. We can see that that's pretty solid as far as a consistent shape. Moving down, where is the second? Don't see any more of those spikes from before, so I'm going to say that they occurred before 557. So I'm going to go back to 517, come back here, there we go. So the spikes that were after this point, after 557, were more consistent. So I'm going to remove this, move to a new scan, get back out of here. I'm going to call this one a discard as well. Now I don't want to get rid of it because I could still use the scan data, because once again, you align multiple scans. Some scans might have different pieces that present a clearer picture, and when you have an extra scan that you set aside, you might be able to use the data in there to go ahead and complete a missing part of the model. So I'm going to hit discard for right now, but I am not going to actually delete that piece. So I got 2 pieces working for me right now. And that's about all I'm going to do right now for breaking down a single scan. But when you do this, I'm going to take this off now, the raw scan of the demo, and I'm going to show you the raw scan data of what I did previously. You can see I did a raw scan before, doing a discard, 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 and another discard, keeping all these together. You can see how I separated. There's a left and a right, and I aligned them. This one was a lot of scan data. This one, and this one. And you could take all these and actually align them if you wanted to. We'll do align and just auto alignment. So it's taking all the separate pieces and putting them together. Once again, if you do not like what it is doing, you can always cancel and manually align them. But it kept it just the way it is. You can apply, and taking all the data, all the different parts of data that you've created, and then aligning them. As you can see, this was one scan that I separated into multiple pieces, and you can align separated scans. Once again, this was able to align, let's see, these pieces to each other, and as well as these pieces that are in the back. So if I take these three off, you can see that was one part of the shell. I had another part of the shell that I had separated, cleaned it up, and then put them together. As you can see, I think I used an eraser feature for some of this up here to erase different parts that were so jagged. And now together they form, let's see, this one, and this one, and this one. All these came together to form this end result model right here. So that's what you can achieve by taking a single scan, getting carving out some of the jagged edges, some of the extraneous data, aligning the separated scans, and then finally fusing them together. And that's the kind of results that you can get. And once again, you see things like this. Just remember to finish off your project in the right way, which would be using the tools, a small object filter that will take care of things like this and like this. Apply, gets rid of it, and then hole filling. That's probably not a bad thing to do. And then mesh simplification, so it can reduce the size down, and so that you can export as an STL. But that pretty much is how we align multiple scans or align scans from a single object that has been broken down into smaller pieces.